Here's going to be our first set of practice problems. So it says simplify each as far as possible. Now keep in mind if we have to rationalize, we need to do that also as part of our simplifying process. Now as I look at this one, I've got the fourth root of 256 over 15. This would be an example of having the same root because, there it is. It's kind of like having the fourth root of 256 over the fourth root of 15. So I want to first see if I can take 256 divided by 15 and simplify it. It doesn't simplify out, so I'm going to go ahead and leave them split up, and I'm going to check if either of them are perfect roots first of all. Well, go down to your x to the fourth column, see if you can find 256. Hopefully you find it across from the 4. So the fourth root of 256 is 4. Now I need to check for the 15. Well, the 15 isn't on my list, so I need to see if I can break it down by anything. So I want to look for things that I can divide into 15, and remember you're only looking in that x to the fourth list. There isn't anything in there, so the last thing I need to do is rationalize this. First though, I'm going to rewrite it using rational exponents. So I'm going to write it as 15 to the 1/4 power. Now I have to ask myself, what can I multiply by in order to get my exponent to be a 1? And when you multiply, you add exponents. So I need to think about 1/4 plus what will give me an exponent of 1. And that would be a 3/4. So what I'll be left with on the top is 4 times 15 to the 3/4 power over 15 to the first, which is just a 15. Okay, this next one looks really messy. The first thing that you want to look at is, notice we have the same index here, so we have the same root. We have the fifth root and the fifth root. I'm going to start by combining them into 1. So I'm going to take my 27 times my 9, and that's 243. Then I'm going to look at my y's, and I've got 2 y's here and 1 y here. So when I multiply those together, I have y to the third. That takes care of those. And then my x's, I have 1 x here and 3 here. So I'm going to have x to the fourth. So when I put those back together, I have the fifth root of 243 y cubed x to the fourth. Now I'm going to go ahead and see if I can break any of that down. So the fifth root of 243. When I go look on my list, it's on there, and that piece turns into just a regular 3. So the fifth root of 243 is just 3. Then my y cubed is still going to stay under there, so I have the fifth root of y cubed and the fifth root of x to the fourth. Now the reason they stay under there is because their exponent is smaller than what our index is. So there's only 4 x's here, and I would need 5 of them in order to be able to reduce it. So this one would reduce down to 3/5 root of y cubed x to the fourth. Okay, here's 2 more practice problems. Go ahead and pause the video and see what you come up with for these. On the first one, I started off by distributing that 5/2 to everything inside here. So I had 10 to the 5/2 and x to the 5/3, because for a power of a power, we multiplied the exponents. Then I did the same thing on the bottom. I distributed the 1/3 to the 7 and the 1/3 to the x squared. So I had 7 to the 1/3 and x to the 2/3. From there, I combined my x's together. They had the same base, so I manipulated the exponents. Well, my rule when I have a division problem is I subtract exponents. So I took 5/3 minus 2/3 and got 3/3, which reduces down just to x to the first power. Now, with my 10 and my 7, I can't combine those because they do not have the same roots. 10 to the 5/2 is really the square root of 10 to the 5th, and 7 to the 1/3 is really the cubed root of 7. So they don't have the same root, they don't have the same bases, so they don't ever get to go together. They just get to kind of sit there and hang out. Once I got to this point right here, I realized, you know what, I have a radical in the denominator. Even though the symbol isn't there, 7 to the 1/3 is really the cubed root of 7. So you have to make sure you start thinking about anytime you have a fractional exponent, you have a radical. So what I did was I asked myself, what do I need to multiply by so I can get that exponent of 1 on the denominator? So I had to take 1/3 plus what value would give me a 1. Well, that would be 2/3. So I took the top and the bottom times 7 to the 2/3 power. And on the top, I just moved the 7 to the 2/3 in the front instead of putting it behind the x. So I have 7 to the 2/3, 10 to the 5/2 x over 7. Now, a couple things I need to point out here. These 7s do not cancel out because they are not the same type of thing. 7 to the 2/3 is really the cubed root of 7 squared. Well, cubed root of 7 is not the same thing as a regular 7, so they do not get to cancel out. This one is all we're going to do for that. Okay, this other one you might have looked at and wondered what even to do, but it's just to demonstrate that it doesn't matter what our exponents are, we follow the same rules. So I distribute this exponent of the square root of 3 to both of them. So I have 5 to the square root of 3, and here I still multiply. So the square root of 5 times the square root of 3, well, they have the same roots, so I can go ahead and just multiply their bases and get the square root of 15.